Use the rational root theorem to find all possible solutions to the following polynomials. Okay, so we're not actually going to solve and do the whole process. We're just going to figure out what are the possible solutions. So number one, here's our polynomial. And let's say that we have this equal to 0. So now we're ready to solve it. So let's figure out what our P over Q options could be. Well, let's start by figuring out what are the P numbers. P numbers are factors of the constant. What's the constant here for this equation? It's a 2. So the P values are going to be all the factors of 2. The factors of 2 are only 1 and 2. So that's what we have for our choices for P. Okay, and then Q is factors of the leading coefficient. All right, so let's look at the leading coefficient. Remember, the leading coefficient is the coefficient in front of the x with the biggest exponent. And as long as your equation is in standard form, that's always going to be the front number. So 6 is our leading coefficient. All the choices for Q are going to be all of the factors of 6. So you could look up the factors of 6 if you if you wanted to make sure you don't miss any. But what do we have? 1 times 6 or 2 times 3. Those are the choices. I'll list those out in order here. So just counting up, we got 1, 2, 3, 6. Okay. All right, there they are. So let's go ahead and make a list of all of our possible solutions. So the possible solutions are going to be every combination of a P number divided by a Q number. So every combination we get here with one of these on the top and one of these on the bottom. So let's start to list them out. And this is what I'll do. I'll start by using a Q value of 1, and I'll see what combinations that we have. So we could have 1 divided by 1. 1 over 1 simplifies, of course, to just a 1. So 1 is a possible solution. Now let's not forget to put plus or minus because it can be positive 1 or it could be negative 1. Okay, staying with the Q value of 1, but moving to the new P value, look, here's a combination that we could get 2 over 1. 2 over 1 is, of course, a 2, so 2 could be positive, could be negative. So what we're doing here is we're generating a list of possible solutions to this equation. All right, let me move to Q value of 2. So we could have 1 over 2, so 1/2. And then here's another combination here, 2 over 2. Now, 2 over 2 simplifies to a 1. And look, we already have 1 on the list. So we're not going to write it again. This is actually just giving us a duplicate. So we'll just keep moving forward. We already have that one. Okay, let's move to a Q value of 3. 1 over 3. And then we'll go here, 2 over 3. Okay, and then the last Q value is 6. So we get this combination, 1 over 6. And then this combination here, 2 over 6. Now, let's see here. 2 over 6 can simplify to 1 over 3, which, look, we already have on the list. So this gives us another duplicate. So we're not going to write that down. Okay, and we've gone through all the possible combinations here. So this here is the list of possible solutions to this equation. Okay, if this equation has any solutions that are whole numbers or fractions, it's guaranteed to be on the list. That's what the rational root theorem tells us.